Hi friends, welcome to VSR Tech Info. This is VS Rao. In this video, quadcopter drone, we will look at the anatomy of drone as well as we will also look at how drone flies. That is, what is the physics behind drone which makes it fly. Nowadays, during this lockdown due to coronavirus, you might have heard and seen drones flying in the sky during day and in night. Drone refers to any unmanned aerial vehicle with a pre-programmed path, basically with no human control. The quadcopter, that is drone with 4 propellers, is the most popular consumer drone. Quadcopter is a multi-rotor helicopter that are lifted and propelled by 4 rotors. These propellers are connected to motors which are driven by electronic speed controllers. Quadcopter use independent rotor speed variation to achieve flight control. Drone consists of a microcontroller, which is just a small computer connected to different sensors that include accelerometer and gyroscope, which provides orientation information. A receiver is also connected to microcontroller, which transfer instructions from remote control to microcontroller. All these things are powered by a battery, usually lithium ion or lithium polymer. Anatomy of a drone is shown here. Drone consists of the airframe with 4 rotors, the propellers, motors, airframe, front indicator, this is a ball indicator, battery pack, landing struts, camera gimbal, electronic speed controller and flight controller with a first person video camera. These are the common drone components or parts. Let us look into the details. Most drones have a number of features in common. Following are the common quadcopter components. Props or the propellers. The propellers of a quadcopter typically consist of 2 standard and 2 pusher props rotating in opposite directions. The image shown here, the low pitch and the high pitch propellers. Motors. Quadcopters use DC or AC motors. There are number of varieties and in different price ranges to choose from. Electronic speed controllers. ESCs convert DC to AC for brushless motors and also trigger the motor's power supply. You will need one ESC for each motor. Since there are 4 motors, you require 4 ESCs. ESC's firmware can be modified to create different motor behaviors. For instance, ESCs are often configured to slow down the motor rather than stopping abruptly. Flight controller. The flight controller assists manual flight with certain autonomous functions. The image shown here is a flight control processor on the flight control PCB or circuit board. For instance, many flight controllers have a tilt sensor that keeps the drone level. Most often, flight controllers will have certain pre-programmed routine they perform if the quadcopter leaves the control range. The image shown here is a flight controller circuit board with the interfaces shown. Motor 1, 2, 3, 4, LED strip, serial bus and trans and receive, battery voltage, 5V ground, RSSI current and the buzzer interface are shown here, and this is the flight control processor. This image is the interfaces that are connected to the flight control circuit board. Lithium polymer battery is connected to the flight control circuit board. The LED strip is connected, and the motor with a ESC circuit is connected to the flight controller, and this is the video in connection from the camera, and this is the video out connection which goes wireless to the remote control unit. Buzzer connection is also interfaced here, and four motors with 4 electronic speed controllers are interfaced to the flight control circuit board. Airframe. Airframe is a proper name for the drone's chassis. The airframe consists of a number of different elements, including motor booms as well as an enclosure or platform for housing the electronics. This is the airframe. The electronics will be placed here. The 4 motors will be placed here, and this is for the camera gimbal, and this slot is for the battery. These are the struts on which the quadcopter lands. Battery pack. Often a lithium polymer battery, the robot's battery pack keeps the propellers turning while also powering whatever onboard electronics. Camera gimbal. This is a rotating platform on which a video camera is mounted. The image shown is the camera gimbal. The camera is mounted on this gimbal. Gimbal and camera control hardware and firmware is inside this box. The anti-vibration mount, you can see, is provided. Servo motors allow the operator to turn the angle of the camera during flight. Landing struts. Quadcopters with a camera gimbal or other protruding things on the bottom need landing struts, which are little legs the drone rests on when it is on the ground. The image shown here is the landing strut. On the other hand, drones without gimbals often do not need struts and simply land with the entire airframe on the ground. Front indicator. Quadcopter operators need to know the front of the hovering aircraft, and it might not necessarily be obvious. Multiple solutions are available, ranging from differently colored props, LEDs and reflective materials, or a colored ball that marks the rear of the craft. All that matters is that it makes sense for you. The image shown here is the colored propellers which indicate front and rear. The front LEDs are shown red and the rear LEDs are shown green. This is the indicator which indicates the front. First person video camera. Low resolution camera that sends its images to a ground station via radio waves. Receiver. This small circuit mounted in a box translates radio signals from remote control into instructions for the flight controller. The image shown here is 2.4 GHz receiver used in drones. How drones fly. Rotor direction. The drone is a quadcopter which has 4 rotors that are connected to 4 individual motors, allowing them to move at different speeds. Rotor 1, 2, 3 and 4 are shown, and this is the drone with the front and rear side indications. The two diagonal motors will rotate clockwise while the other two diagonal motors will rotate anti-clockwise. If we notice, rotor 1 and motor 3 will rotate in clockwise and motor 2 and motor 4 will rotate in anti-clockwise. The two opposite rotations balance out and keep the drone steady. So if all the rotors were to spin in the same direction, it would result in a net torque causing the complete quadcopter to rotate. Vertical lift. In order for a quadcopter to rise into the air, a force must be created which equals or exceeds the force of gravity. The quadcopters use motor design and propeller direction for propulsion to basically control the force of gravity against the quadcopter. When the rotors spin together, they push down the air and the air pushes back up on the rotors. When the rotors spin fast, the drone lifts up into the sky, and when the rotors slow down, the drone will descend towards the ground. Now a drone can do three things in the vertical plane: hover, climb or descend. Hover still. To hover, the net thrust of the four rotors push the drone up and must be exactly equal to the gravitational force pulling it down. Climb, ascend. By increasing the thrust speed of the four quadcopter rotors so that the upward force is greater than the weight and pull of gravity. Vertical descent. Dropping back down requires doing the exact opposite of the climb. Decrease the rotor thrust speed so the net force is downward. Drone rotation. When you want the drone to turn, you slow down two of the diagonal motors and you speed up the other two diagonal motors. The image shown here, the drone is turning towards the right direction. Motor 2 and 4 will now rotate slower. Motor 1 and motor 3 rotate faster than 2 and 4. Therefore, the drone turns right. By slowing down two motors rotating in one direction and speeding up the motors in the other direction, the drone will accelerate as fast as possible from the ground depending on how fast the propellers rotate. The lift will remain constant, so the drone does not change height, but angular momentum is increased, thereby drone will turn right. Forward and backward. If you want the drone to move forward or backward, you slow down two motors on one side of the drone and speed up the two rotors on the other side. The example shown here, motor 1 and 2 are made slower, motor 3 and 4 are made to rotate faster, thereby the drone will move forward. The drone tips slightly towards the slower side and move in that direction. The image shown, the drone is tilted slightly towards the slower side and is moving in that direction, that is forward direction. If you want to move sideways or backwards, we just need to use the same principle on the other sides of the drone. Now if you want to move this drone on towards the left side, 1 and 4 motors to be made slower movement and motor 2 and 3 to be made speed. Thereby the drone will move towards left. Remote control. The way we control the rotor speeds of the drone is by using the joysticks on the remote, which work to increase or decrease the voltage being delivered from the battery to each of the 4 rotors. If a motor is getting more voltage, it is going to rotate faster. All the necessary actions are performed using remote control to maneuver drone. Attitude of the drone. Attitude just means the angle or tilt of the copter. relative to the ground. Attitude provides information about an object's orientation with respect to the local level frame, that is horizontal plane and true north. The image shown here is a flight. Pitch, yaw and roll are shown. Wing up or down is equal to roll. Nose up or down is equal to pitch. Nose left or right is equal to heading, yaw or azimuth. Attitude solutions typically consist of three components: roll, pitch and yaw. The easiest way to understand attitude is to consider a drone with three linear axes running through it: vertical axis, horizontal axis and z axis. Roll. You are flying your drone and you want to rotate it for 180 degrees. How do you do it? If you want to roll your drone towards the left, then you need to increase the thrust on the right motors and at the same time decrease the thrust on the left motors. If there is no torque on the drone, then the total angular moment must be 0. Pitch. What is the difference between moving forward or backward in a drone? None, because the drone is symmetrical. This is the drone, and as such there is no front, rear or side for a drone because it is symmetrical. So if you want your drone to fly forward, you will need a forward component of thrust from the rotors. So how we will do this? First thing you need to do is to increase the rotation rate of rear rotors and decrease the rate of front rotors, and therefore thrust force will remain equal to the weight. We know that one of the rear rotors is spinning counterclockwise and the other clockwise. The increased rotation of those rotors will still produce zero angular momentum. Yaw. When we use the term yaw in terminology of drones, it is defined as rotation of the drone with respect to center axis. The image shown here is the center axis and this rotation is yaw. When we talk about yaw, it has the origin at the center of the gravity of the drone and it is directed towards the bottom of the aircraft. The term yaw is also called or known as azimuth. Drone gyroscope. The most common sensor in drone is the gyroscope or gyro. The electronic gyroscope is a device that serves to stabilize the flight and hold the position. This is the gyroscope circuit board, which is 3-axis gyro. The rotation are indicated with X, Y and Z axis. A gyroscope uses Earth's gravity to help determine orientation. Some of the external objects can be cause of them, like wind and inertia of the aircraft, as opposed to the intentional remote control signal. With gyro, we can very accurately stabilize the flight of the multi-rotor devices. The image shown here is the physical gyroscope. Accelerometer. As the name implies, the accelerometer measures drone's acceleration forces which help in maintaining the drone's orientation. The circuit board shown here is the accelerometer sensor ADXL335, X-axis, Y-axis and Z-axis. This is an electromechanical device and the forces that accelerometer measure are the force of gravity or dynamic to sense moment force. Accelerometers are made up of multiple axes, two to determine most two-dimensional movement with option of a third is used for 3D positioning. The image shown here, a drone with various sensors. inertial measurement unit, accelerometer sensor, engine intake flow sensor, magnetic sensor, tilt sensor, current sensors are shown as an example. Drone radio control system. Drone radio control system have two elements: the transmitter you hold in your hands and the receiver you put inside your drone. In the simplest way, it would work like this. Your drone transmitter will read your inputs and send them through the air to your receiver in the real time. From this remote transmitter, the inputs are collected and sent through air to the drone receiver. When receiver receives the information, it passes it on the drone's flight controller, which makes the drone move according to your commands. Thanks for watching. Subscribe and like VSR Tech Info.